Hey guys, welcome back to my channel camnotion.com. So as we are solving Dibrugarh University MSc Chemistry question paper 2019, as you can see this is part 5 and this is presented by me. Guys, do subscribe to my channel. If you like my explanation, share it and press the like button. So let's begin the video. In our first question, we have the correct order of second ionization potential of carbon, nitrogen, oxygen and fluorine. In the question, it is asking about second ionization potential, not the first one, not the first ionization potential. Now, since we know that, let's take first carbon atom. We know that the outermost electronic configuration for carbon atom is 1s2. 1s2 is the electronic configuration of carbon atom is 1s2, 2s2 and 2p2. Now, since it is asking about second ionization potential, it means there already one electron been removed from the outermost orbital. That is, it is 2p1. The configuration will be 2p1. Now, see, ionization potential means the amount of energy required to remove most loosely bound electron. Now, in this configuration, the amount of energy will be required to remove this electron. This particularly electron will be very less, in the sense that carbon atom will be very happy if it can remove this lonely p orbital to gain a noble gas configuration, that is 1s2 2s2. So for this particular configuration of carbon, the ionization potential will be very less. That is, a very less amount of energy will be required to remove this particular electron. From that, we can easily eliminate this option A, which is just carbon atom will not have a highest potential ionization potential. But in option B, C and D, we have carbon at the least. Let's check for oxygen atom. We know for oxygen atom, outermost electronic configuration is 1s2, 2s2 and 2p4. Now one electron has been already removed. Now it will be 2p3. Now since 2p3, that means what? It is a half-filled electronic configuration in the p orbital, which is just a stable configuration. Now if somebody wants to remove one electron from that stable orbital configuration, which is just it definitely requires some large amount of energy, so that one can remove an electron from this particular orbital. So the second ionization potential for the oxygen atom simply will be highest. That is, a very large amount of energy will be required to remove an electron from this particular stable 2p3 orbital. Now, between nitrogen and fluorine, we can assume a simple idea that fluorine is the most electronegative element on the earth. That means one cannot easily remove an electron from fluorine atom. That means what? Right after the oxygen, fluorine must have a more ionization potential. Then it will be nitrogen, and at last carbon atom, which is simply have one can easily remove one electron from the 2p1 orbital. So the right trend of second ionization potential of these atoms will be oxygen, right after it fluorine, then nitrogen and then carbon. So this question, for this particular question, option C will be the right option. So that second ionization potential of oxygen is highest. Moving to next question, the correct order of acidity. Now if you can just determine which one is more acidic by uh, drawing it conjugate bases. For HF molecule, for HF conjugate, its conjugate base is, that is, just removing one minus, is there is F minus. F minus is the conjugate base of hydrogen fluoride. Now see, F minus is a very unstable compound. That means unstable in the sense that since fluorine atom is very small, small atom, very its size is very smaller. So if someone add one more electron, so which creates some additional hindrance into the compound, which just unstabilize the fluorine atom. So F minus is least stable, is a less stable species. That means first it is more reactive, or in the sense you can say it is it is more basic compound. It is more basic compound. Okay, now we know that for a compound which is more basic, its conjugate acids, that is HF, will be the least acidic. That means that means HF is a least acidic species. That is, and for HI, if we for HI, its conjugate base is I minus, which is not a good base, or you can say which is not reactive in the sense because of its large size. Since it is not a good base, its conjugate acid will be the highest acidic. Right. So HI is the highest acidic and HF is the least acidic compound. So HF is the least acidic compound, right? So now now it will follow the trend, HI right after HBI, then HCl, then HF. So for this question, right option is B. Also, you can solve this question by taking some generalized idea that HF molecule, since fluorine atom is a very small atom, so the bond between H and F is very small, so a large amount of energy will be required to break it. But in the case of HI, the bond is very it is not a short bond, it is a longer bond, so that one can easily break the bond, so that H plus can easily be removed out. So HI will be the most acidic compound. So but this is not a correct explanation, but you can just assume that things what's going on is right, like things, right? So for this question, option B is the right option. Moving to next question. The decreasing order of acidity of oxides of boron, aluminum, carbon, silicon follows the order. Okay, right? So for oxides, you need to know one thing, that when any compound, any species like S, when attached with oxygen, any species like S is not sulfur here, it is just I am taking an example of S as a compound which when attached with oxygen, that forms an oxides. The electronegativity difference between oxygen and the species which is just attached with oxygen, if it is more, then it will be least acidic, and if the electronegativity difference is less, between this species and oxygen, then the acidity will be more, then the oxide will be more acidic. Now let's go into the options. Here we have CO2, carbon dioxide, SiO2, B2O3, and Al2O3. Now since carbon atom is 14 group element, and boron is a 13 group element, and they are like they are positioned in the periodic group like carbon, boron, here it is silicon, and here it is aluminum, right? So we know that along any period, electronegativity always increases. Therefore carbon among these four will is the most electronegative among these four. Carbon will be the electronegative most. Then right after it, we know that down the group electronegativity decreases, so silicon will be less electronegative than carbon, and also than the boron. So right after, so CO2, since CO2 is more electronegative than rest, so the electronegativity difference between oxygen and carbon will be less, will be, you can say, least among these three oxides, four oxides. So in option B and C, the CO2 is given as the highest acidic oxides. So the right option will be either B and C. Then since boron is right next to carbon according to electronegativity, so B2O3 will be acidic species right after the CO2, and then it is SiO2, and at the least Al2O3, because along the period electronegativity increases, SiO2 here, and Al2O3 uh, is is right to the is left to the silicon. So aluminum will have least electronegativity. So for this question, option C will be the right option, right? So CO2, the compound C, or the oxides CO2, that is carbon dioxide, will be the highest acidic among the four, and aluminum trioxide will be the least acidic species. Okay, so moving to next question. Yeah, Epr spectroscopy is often used to investigate carbon 2 complexes but not carbon 1 complexes. This is because, right? So here one statement is given that Epr spectroscopy. Yeah, let me tell you what is Epr spectroscopy. It refers to the electron paramagnetic. Okay, so the most important term here, paramagnetic, right? So the term Epr spectroscopy itself defines a electron paramagnetic resonance, that is paramagnetic, that is one unpaired electron must be there, in the complexes, so that that compound can be investigated under this spectroscopy, which is the basic you call it requirement for this compound. Now see, as the statement is saying that copper 2 can be investigated but copper 2 not, since copper the outermost in the outermost electronic configuration of copper 2 plus is 3d8 4s0. So 4s 0, sorry, 3d9, sorry, it's 3d9. So in case of 3d9, there must be an unpaired electron present. There must be an unpaired electron present in the 3d9 species. That's why this copper 2 complexes can be investigated under this Epr spectroscopy. So in option B and C, it is given as copper 2 plus as D9 configuration, which is the right option. Okay, which is the right statement, or you can say copper 2 plus, here also it is given D9 configuration. But for copper 2 plus, we need to know the outermost electronic configuration of copper plus. That is, in copper plus, one electron is removed from 4s1 orbital, and it is D3d9, right? But the thing which is just which is there in which is to be considered in the case of copper plus is that this 4s1 electron is just shifted to 3d orbital, so that it can have stable 3d10 fully filled electronic configuration, which just stabilize this ion, that is copper plus. The stable configuration of copper plus is just 3d10, that is in the option C, it is given as copper 2 plus has 3d9 and copper plus has 3d10, right? And in 3d10, there must not be any unpaired electron, so that it cannot be investigated under Epr spectroscopy. Also, if you don't know the electronic configuration of copper plus, also you can solve this by, if you know the term Epr refers to that electron paramagnetic resonance. Paramagnetic means there must be a presence of unpaired electrons, but here, as you can see, S1d9 configuration, there is one unpaired electron will be there. Also, if this electron configuration will be it will be the electronic configuration for copper plus, then Copper plus can also be investigated under Epr spectroscopy, but the things which is not there in the case, but which is not happens. So copper plus has D10 configuration, and which is the right option, right? So moving to next question. Yeah, oxyhemoglobin and oxymyoglobin and oxyhemoglobin respectively are. Yeah, so oxymyoglobin is a diamagnetic and species, and oxyhemoglobin is also diamagnetic. Okay, so for this, option B is the right option. Also, I would like to tell you that if you remove the oxygen molecule, if you remove the oxygen from the oxyhemoglobin, that is deoxyhemoglobin is a paramagnetic substance, right? Keep in mind it is paramagnetic, but oxyhemoglobin is diamagnetic. Okay, right. For this question, option B is the right option. Moving to next question. A well-known naturally occurring biological organometallic compound. Okay, right. Now organometallic compound in which in organometallic compound in which a carbon atom is just attached with an metal atom, but in case of hemoglobin, iron atom is attached with nitrogen, so it is not the or not an organometallic compound. Also chlorophyll, there is not an there will be not there is not any CM bond present, and also in case of myoglobin, which is not there in the there. And so right option is vitamin B12 coenzymes, that is simply vitamin B12 is an organometallic compound, right? So for this question, option B is the right option. Okay, for this question, right option is option B. Moving to next question. Yeah, smoke pollution is due to heavy metal pollution. No, guys, this is not a heavy metal pollution. Smoke doesn't contain uranium like metals. Arsenic and fluoride pollution, which is not which is only be considered when it is when the question is asking about pollution of water pollution, and this is not a water pollution also. And for this question, option D is the right option. Small particulate pollution in the air. Okay, when we burn things like tire, the small pollutant particles are goes into the air, so that it can pollute the air, and we get smoke pollution, right? So moving to next question. Which type of isomerism is shown by the following compound? Right, I have just forgot to write the options here, but let me tell you the answer here. This is simply this is basically an ionization isomerism. Ionization isomerism. Okay, ionization isomerism, because if you ionize the compound, for the first compound, if you ionize the first compound, then you will get SO4 2 minus ion, and if you ionize this compound, you will get bromine minus ion. Okay, but in both the case, anions are different, because you can see the species just above, um, bromine and sulfate ion is different. So this is an ionization isomerism, right? So moving to next question. Which of the following is a paramagnetic, right? So paramagnetic substance, to be paramagnetic substance, there must be a presence of unpaired electron, as I have already told you. We have already discussed that. Now in option A, the nickel, since CO is an neutral ligand, so nickel is in plus 2 state. Nickel is in plus 2 state. Also in option C, nickel 4 minus 2, nickel is in plus 2 state. Also in case of option D, NiCl for 2 minus, nickel is in plus 2 state. Now nickel is in plus 2 state, that means the outermost electronic configuration is 3d8, right? 3d8, so that it will be like this, 3d8. Now since in here 2 electrons are there, so it must be unpaired electron, but but this is not an MSQ type question, so that both three options can be correct, right? So let me tell you the thing what is happening here is that CO is a strong field ligand, Cn is a strong field ligand, but Cl is not an strong field ligand. So we know that the electrons under the environment of a strong field ligand, they just paired up, and the configuration of D8 configuration would become like this, and there will not be any unpaired electron present in the case of option A and option C, because in both the cases D strong field ligands are present, but in the case of option D it is NiCl4. We know that chlorine is not an strong field ligand, which is a weak field ligand, so that it is just unable to pair up the electrons. For that, the electrons, there will be a two unpaired electron will be present for NiCl4, which is just a paramagnetic substance, right? For this question, NiCl4 is a paramagnetic substance. This is the last question. The ground term for D2 configuration, right? Now we know that to calculate ground term, we just to know this is a generalized form through which we can calculate the ground term of any configuration, right? Now for L, since it is given that we need to calculate D2 ground term for D2 configuration. For D, L value is F, right? And if you calculate, since it is D2, if you calculate 2s plus 1, the value will be comes out to be 3. Okay, right? So the right option, and the Z value may be 4, 3, 2, and the right option here, and which we need to take is 2, and the right option here will be 3f2, right? For this question, and for ground term for D2 configuration is 3f2. So I hope you guys like this, and if you like it, hit the like button and share this video, and thanks for watching.